the basic concept of completing the square. Let me explain to you through this example. Let's say we have quadratic expression of x squared plus 10x minus 9. To do the completing the square, so first of all, we must make sure that the coefficient of x squared is 1. Then we add and subtract the new term that we form by using the square of the coefficient of x divided by 2. That for these cases, that is 10 over 2 square. So we add and subtract. After that, we simplify this expression. For the x squared plus 10x plus the 10 over 2 square, we simplify it as the x plus 10 over 2 square, followed by minus 9 minus 25, and we simplify the whole expression to get it x plus 5 square minus 34. So this is how we do the completed square form. Let me show you a shortcut approach that we call as big square minus small square technique. We can represent the quadratic expressions geometrically as the sum of the area of a square with side length x and the area rectangle with side length 2b and x. Splitting the red rectangle down the middle, we can place it on either side of the blue rectangle to form a big square. However, the actual area is the area of big square subtract with the small square, that is x plus b square minus the b square, which is also the completed form of quadratic expressions. Let me show you how you're going to apply technique of big square minus small square in converting quadratic expression in completed square form. For example, we have a quadratic expression of x squared plus 10x minus 9. In applying the technique of big square minus small square, we only consider expression of x squared plus 10x. We can represent it in geometrically. So we were going to get a square of side of x and the rectangle of side of 10 and x. In order to form a big square, we need to divide the coefficient of x. For these cases is 10 divided by 2. So we are going to get 5. So now the side of big square is x plus 5 and the side of the small square is 5. By applying the technique of big square minus small square, so we are going to have x plus 5 square minus 5 square. Now we copy the result into the actual questions. We simplify it and we will get x plus 5 square minus 34 as the completed square form of x squared plus 10x minus 9. We proceed with the next example with the expressions of x squared minus 4x plus 5. We represent x squared minus 4x geometrically. We will get a square of side x and a rectangle of side minus 4 and x. In order to form a big square, we divide the coefficient of x, that is minus 4, with 2. We are going to get minus 2. Now, the side of big square is x minus 2 and the side of the small square is minus 2. By applying the concept of big square minus small square, we are going to get x minus 2 square minus minus 2 square. We copy the result into actual question and we simplify it. We are going to get x minus 2 square plus 1 as the completed square form of x squared minus 4x plus 5. Well, how are you going to apply the technique of big square minus small square in converting the quadratic expression? We have the coefficient of x squared not equal to 1. For example, we have the expression of 2x squared minus 5x minus 7. Before we applying the technique, we need to do some factorizations words as shown in the screen. After that, we are going to represent the x squared minus 5 over 2x geometrically. So we are going to have the square of the side of x and the rectangle of the side of minus 5 over 2 and x. In order to form a big square, we need to divide the coefficient of x, that is minus 5 over 2 into 2. We are going to get the minus 5 over 4. Now, the side of big square is x minus 5 over 4 and the side of the small square is minus 5 over 4. By applying the actual area of big square minus small square, so we are going to have the x minus 5 over 4 square minus the minus 5 over 4 square. So we copy the result into the actual question and we do the simplify until we are going to get the completed square form as 2 of x minus 5 over 4 square minus 81 over 8.